Hi friends, today I'm going to give you a few interview tips for any type of cloud interviews and also the commonly asked questions for any type of cloud. So these are the few words you can commonly use during your interviews. Based on the question and based on the situation, you can adapt these type of words to improve the terminology. Let us jump into the topic. So you usually need to use scale up and scale down, upscale, downscale. So for example, if you're using the number of servers, then you will either upscale or downscale that particular virtual machine or any type of other resources. Then you will also scale it up or scale it down based on the type of requirement you have or based on the traffic it is coming. So the next one is burst. Burst usually is a cloud bursting architecture, which is flexible architecture that provides cloud consumers with the option of using cloud-based IT resources only to meet higher uses of demands. Not just for the architecture, you can also enable the bursting on the EC2 instances or VM instances. Only few type of instances such as like T3, T3A, T2 instances can be burst or based on your business needs. Like say you want to improve the CPU performance or you want to just bring it up to the higher level of that particular CPU. So it's basically a term which is usually used for the architectures, like you're designing a cloud bursting architecture so that you can meet the high business demands or higher usage demands. At the same time, if you're using the low level or the base level instances, then if you want to just burst to the high level based on the demand or traffic coming more onto your instances. The next one is vertical scaling and horizontal scaling, which you usually need to use during the interviews. Vertical scaling is something within the mission you're upscaling the various resources, like adding more memory, more computing power and other stuff, more storage. Coming to the horizontal scaling, like adding more computers. So for type of NoSQL databases, you usually go with the horizontal scaling. For the regular SQL Server relational databases, you usually go with the vertical scaling. Similarly, for various type of applications, you can't go with the horizontal, but you can go with the vertical scaling. Coming to the microservices and all those stuff, you can go with the horizontal scaling as well, just not like vertical scaling. Both can be applicable. Coming to the next one, scalability, adaptation, portability, compatibility. These are the few parameters or few terms you usually use for architecture level stuff. So you need to always consider the scalability when you are designing any application, cloud-based application, because business might be with 10,000 users today, but it may grow up to the 10 million users within the next 5 years. You should consider the scalability of your application and to meet your architecture for those business needs as well. Adaptation, so how quickly you can adapt the cloud or adapting the various features, leveraging the various features of the cloud to give the best architecture. The next one is portability, so how you can port from one particular cloud to the other cloud. Compatibility, whether your VMs or the various infrastructure components you are using in your on-premises are compatible to move to the AWS or Azure or GCP. So that's how you can play with those terms. I'm just giving one simple sentences, but you can adapt those words in the various scenarios. The next one is vendor lock-in. For example, if you're using the Azure and maybe like native features such as Azure Functions or maybe Event Hub or maybe data lake storage, that means you are just locking into the vendor and you're designing your whole architecture and whole application or whole deployment architecture as per the particular vendor, and then you're locking into. If you want to switch to the other cloud vendor, then again you need to re-architect that particular stuff as per the other vendor. That's where the vendor lock-in will come into the picture. But yeah, you can design your architecture or the cloud application which is independent to the cloud vendor without logging into. Maybe like after 4 years or 5 years, if the customer realize and then want to move to the other cloud, then your architecture will really help with the less cost model to move to the any other cloud. So the next term is high availability. Most frequently used word is high availability. Any type of application which you are designing on the cloud should be considered with the high availability and disaster recovery. So high availability is always comes with SLAs like 99.99 SLA, that is 4 nines or 11 nines. That will decide like how much downtime it is going to be in a month or in a year or in 10 years. So you always need to consider the SLAs and also the high availability strategy, like how many servers you are putting in, or what is your failover strategy, and what is your disaster recovery strategy. So disaster recovery is like if some incident happens in the particular data center, you should have some kind of disaster recovery strategy so that your system will be up based on the RTOs or RPOs, recovery time objective, recovery point of objective. So these two terms will define your entire disaster recovery strategy. So it all depends on the compliance of your systems and SLAs, like what SLAs you want to meet. So based on that, you will need to design whether you want to create a replica of your entire system in the other region, or you want to just take the backups of your system and then restore whenever the incident happens. Maybe it takes like little more time than replicating the systems, right? If you have replica of the systems, immediately maybe within 5 to 15 minutes time you can recover entire site and then put it back to the production. But in case if you're only taking the backups, then it will take maybe 1 hour or 2 hours based on the type of workloads you are managing on the cloud. So your disaster recovery is one of the frequently used word. Failover, like if your system A is failed and then you should automatically fail over to the system B. That's what failover is. Like you should have the failover mechanism when you're designing the applications. Load balancing is just not for architects, it is also for administration guys to use this type of terms. It's a quite commonly used terms in any cloud related jobs and cloud related architectures and administration. So the next one is load balancing. So when you are designing any application on the cloud, or you're deploying any application to the cloud, you should also have a load balancing. We never know what type of traffic comes or how big traffic comes into, right? Today you are anticipating that 100 concurrent users are getting into your systems. Tomorrow it may come like 1,000 users. Maybe after a year it will be 10,000 concurrent users. So you should have load balancing architecture and load balancing resources in the place so that you can easily balance the load and you can easily upscale or downscale those servers based on the traffic coming into the server. So load balancing, again, every cloud provider has its own load balancing system. Elastic Load Balancer from the AWS. Again, in the load balancer, like they have classical load balancer, network load balancer. Azure has traffic manager, application gateway, and the load balancer. So various options available on load balancing, like on what type of level you are going to enable this, whether TCP or HTTP type of load balancer. So the next terms are disparate data formats and different silos. Disparate data is with variety in data formats. Like if you see any data, especially in the big data, there are different type of data like structure, unstructured, semi-structured type of data, which is heterogeneous data, right? So that's where you can use disparate data, missing values, inconsistency, ambiguous records. All those things will come under this disparate data, which is like low quality, you can say. So coming to the different silos, silo describes any management system that is unable to operate with any other system, meaning it's closed off from the other systems completely. So you can use this based on the type of environments you are creating or managed services you are creating. Resilience is the most frequently used term in the cloud, again, because the capacity to recover quickly from the difficulties, that which is one of the biggest characteristic of any cloud, right? So that's why we use resiliency of that particular system, resiliency of the data, in similar way like we use in many situations. Coming to the next one, security model, frameworks, approaches, performances, best practices, strategies, standards, policies, guidelines, metrics, measurements. These are the quite commonly used terms based on the various situations coming up in your requirements. So you should definitely design a security model, or you can design your own framework for your cloud adoption. Then what is your approach? In every stage they will ask what is your approach, what is your cloud migration approach or server migration approach. So, and you have to always consider performance, and you have to always consider the best practices for each and everything, like what is your best practice for big data adoption, what is your best practice for identifying the resources on the cloud, what is your best practice for maybe the SQL Server migration. So there are plenty of things like where you can use the best practices, right? So strategy is again, if you are doing a cloud migration, you should have some cloud migration strategy or cloud adaptation strategy, or maybe some big data adaptation or big data strategy, right? So for everything you mostly use all these terms like standards, policies. You must need to have some policies in place. Without that, if you're creating any architecture on the cloud, it is going to be useless. So you should always maintain the policies, and then you should also have certain guidelines before you design those. Best practices, metrics, measurements also similarly used in various situations. Dark data, so never used and never analyzed data is called dark data. So I mean, you don't frequently use this definitely, but when you're talking about data engineering, data analysis, then you will talk about dark data, which is never used and never analyzed. That means literally it is isolated and kept idle. Then journey to cloud, you can also use this term. My journey to cloud started this way, or our journey to cloud for the migration started this way. The next one is data center consolidation. This is another term like consolidating the various resources in the particular data center to move to the cloud, or maybe to save the cost. Your data center in on-premises data center itself, it is being optimized or consolidated, not even without moving to the cloud. So the various ways you can use that again. Moving to the next slide. Advantages and concerns. This is the most frequently asked question. That is the reason I just listed down few advantages and few concerns the customer have. Again, the concerns can be taken as disadvantages. Few of the concerns can be taken as a disadvantages of the cloud as well. Okay, coming to the advantages, innovation. You can always innovate the things which you are designing onto the cloud. Time to market. It is very fast to move to the market, because if you're designing your entire data center, again you will end up designing your data center, your failover servers, your recovery, disaster recovery, backups, archivals. So you will lose plenty of time only in designing the stuff in your data centers and configuring those stuff. But when it comes to the cloud, it will be very, very fast compared to your on-premises data center setup. New features. So there are plenty of new features coming up, and you can easily adapt them. Usually if you have to do it on premises, you have to implement all those features by your own. Flexibility, scalability, availability, not owning hardware anymore. Less management, because the hardware is all being managed by the cloud provider, cloud vendor. So management is almost very less compared to the data center. Cloud gets scaled whenever you have more demand. Also you can downscale whenever you have less demand. So majority of the expenses are spent on the maintenance of the data centers, while that is not in the case of the cloud computing. These are the few advantages you can explain in your own way. But these are the most commonly asked, like concerns, especially vendor locking. I already spoke about vendor locking. lock in, network dependency, limited features, compliance. So when I'm calling limited features because the features which are supporting by the GCP may not be available on Azure. Again, the same thing may not be available on the AWS. So you may need to go with the multi-cloud approach or hybrid cloud approach, right? So next one is compliance. Not all compliances may not be supported. I know that PCI, HIPAA, GDP are supported by the cloud vendors, but in those also maybe the old versions are not supported, or the particular versions you are looking for may not be supported. Loss of data. Sometimes the data may be lost due to some XYZ reason, right? Even if you know, Amazon lost the many records in 2011 time. So data storage, business continuity, uptime, data integrity in cloud computing, data breaches, security, cost, due diligence. These are the few concerns every customer have, or few customers have. So you should be able to address those to convince them to bring it to the cloud. The next one is security concerns, especially if you banking customers or maybe like enterprise architects are not so much convinced, and they have a few security concerns, especially the one I listed down here. So data breaches, especially when they have sensitive data on the cloud. So their question is like how this being protected, though there are so many security measures and security features available on the cloud. The next one is compliance violations and regulatory actions. If you know, like if any compliance violation happens, there will be like huge penalties on that particular one, like regulatory actions will happen, especially if you have GDPR, if your system is not GDPR compliance, especially in Europe area, they give a penalty of millions of euros or millions of pounds. So even similarly like HIPAA or GDPR or PCI, so these are all need to be addressed through your systems. In case if the cloud is not providing entirely this, then they will have regulatory actions against to them, right? So that is the reason they are very concerned about that as well. Contractual breaches with customers or business partners, malware injections, data loss, hijacking of accounts, abuse of cloud services, denial of service attacks, inability to monitor data in transit to and from cloud applications. These are the few concerns, but yeah, definitely there are so many features which can address many of these, but still, they are somehow not completely convinced. But you can take and demonstrate various case studies and also show them what are the features it can bring it up, and how we can leverage all the security features from the cloud. Moving on to the next one. So I listed down what are the security concerns and how the shared responsibilities model for security in the cloud. If you see all these red marked lines need to be managed by the customer, and the grayed ones are managed by the cloud provider in terms of the security. So in on-premises anyway, everything should be managed by the customer or by you if you are managing that particular data center. And then coming to the infrastructure as service, if you're using, definitely plenty of the stuff need to be managed by you, like network traffic, operating system. But yeah, there are features available like DDoS enablement, DDoS attacks, protection, or application firewalls. All the stuff you need to enable on top of it. But your design and your maintenance and management. Coming to the PaaS, there are plenty of things which are managed by the cloud vendor, like operating system, network traffic, hypervisor, infrastructure, physical. But still, your user access, your data, your applications need to be managed by you, because your data is saved by you, and you should have the right strategy to back up for the archival. User access also, if you're giving an unexpected or unwanted authorization to any user, they may misuse it, right? Similarly, in the SaaS model, you should manage your user access and data, but applications will be definitely managed by them because it's in software as a service model. The next one is most commonly asked question. I'm not going to answer all these questions here, but you try with your own answers. I'll come up with more series with the answers for this slide and the next slide as well, but let me just walk through what are the questions. Most toughest or challenging project among you handle? What are the various challenges we usually face? What is the biggest migration you have done so far? How do you convince your customer for cloud adaptability? What are your considerations for cloud adoption? How do you decide which cloud is best for your requirement? How do you secure customer environment? Explain Azure AWS DevOps architecture. What is your approach to the cloud? 90% of these questions are already covered in my interview question series. I made almost 8 parts of interview questions. Please go through those videos. You will find all these answers in that. If you can't cook your own story, you can definitely follow that. Coming to the next one, use case based questions. So these are a few things like they will come up to see whether you have any solution, or at least you are putting some thought process on it when they get some customer requirement. Customer is on LAMP stack. How do you recommend the cloud, or what is your approach? Customer is on .NET stack. What's your approach, or what is your recommendation on the cloud? Which cloud you recommend? Again, it's case to case, right? .NET stack, and if they are using some kind of IaaS and SQL Server, then mostly you may more lean into Azure. But again, you have to put every entire pros and cons of each cloud based on the stack they are using and number of servers they are using, and then finally you can conclude on it, right? So again, they may ask the same question like with Java stack or mean stack, min stack. There are plenty of different stacks available. So customer is building new projects. What's your approach? It's altogether a new project which is not existing. Then what is your approach? Customer have monolithic based application. What's your approach to upgrade? So if the customer has monolithic, definitely you will go with the re-architecting, like first monolithic to microservices. And while you are designing the microservices, you have to consider the various factors on the cloud. What kind of features, whether you want to go with the cloud native or you want to just purely go with the IaaS, that is infrastructure as a service based architecture. Then you can explain all those well. Customer is building simple web application, web services, database. What's your approach? So again, you will understand first what is the application stack, and what is their business anticipation for next 5 years, and how many servers are needed. All those things, everything will come into the picture. Even these questions I covered in my interview question series. Please go through them. Customer is using currently MySQL, but he see a lot of traffic eventually, and also huge amount of data, millions of records. What's your approach? Customer is using currently on-premises SQL Server with single server, but he has potential to get plenty of data and expecting high availability. What's your approach? Customer is fed up with malware attacks on his production servers. What will you recommend for short-term and long-term plans? Customer have on-premises servers and he doesn't want to move those to cloud, but he's looking for big data solution, but he's fine to move to the cloud for new solutions. So these are the various things just to understand your thought process. Coming to the customer is fed up with malware attacks. Definitely you can enable the security center for your, even for your on-premises workloads. Similarly, AWS and GCP has various features. And coming to the long-term plan, you can bring those workloads to the cloud and enable the various layers of security. But if they want to just continue with on-premises, they can enable Security Center, Azure Sentinel, and then plenty of other security layers, even for the on-premises. Customer have on-premises servers and he doesn't want to move to the cloud, but big data solution. Again, you can bring up AWS-based big data architecture, or Azure-based big data architecture, or GCP-based big data architectures for this type of scenarios. So before I wind up this session, I would just want to show you where my videos for the interview questions are. You can see AWS real-time interview questions and also Azure real-time interview questions here. At the same time, there are a couple of videos on the real-time scenarios as well. You can just go to my videos here and then search for them. You can see real-time scenarios and migration series, real-time scenarios for the Azure AWS. So you can go through those videos to get more knowledge, or just to understand what are the typical questions asked during your interviews. I usually cover real-time interview questions based on the real-time scenarios. Thanks for watching my videos. Please subscribe to my video channel.